Okay, we're on 19. We are, of course, we're not dealing with this. We were done with this. Now we do, last time we did a, let's see, 2 times ago we did the dy dx equal to y, and last time we did a special, actually a little more complicated case, which is we put a k on it. And the k, as we can imagine, that just shifts the y coordinates.
Yeah.
Like what we can imagine in the chart, such as this one. It shifts this field. And what was I say? Yeah. This time we do a situation that's a little bit more, which is why now we're gonna write this because this is getting a little messy. We're gonna write this way: y prime plus p y equal to g. Okay, this is y equal to ft. Okay, yt, it doesn't matter. Okay.
Okay.
This constant now start to change with t. Okay, y is still y. Okay.
Yeah.
How are you gonna solve this?
So, wait, what do you want us to solve?
What's the ideas? What's the thought?
Wait, what is...
How do you solve this?
To solve what?
Oh, I want. Oh, you know this is dy dt.
Yeah, I know that, but what's...
I
what
want-
are
I
we
want-
solving?
I want this. Without the differentials. When there's a differential equation, right? Like this. In this case, right? This is the y prime. This is if I write it in that way, right?
Yeah.
Minus ry equals to k. Right? Yeah, equals to k. I want to solve this equation, right? You say you just ask what do you mean by solving it? I mean, this is the differential of y. This is the y.
Okay, yeah.
When you solve it, I mean y equal to something.
Yeah, I got it. I got
Yeah.
it.
Okay. Now, what's the idea? When you look at this, what's the
Just
idea?
put this on this side and then integrate
Put
both
what?
sides.
You go do it.
Put,
And then do what?
integrate both sides.
How do you integrate? There's a y here. Wait. You can. Okay. Let me write up. Okay. Let me open it up. When you write this before the integration sign, right? It's dy dt equals to gt, right? Gt minus pty. Both sides are not infinitely small things. They are normal number. This is a slope. It's normal number. In the past, before we take an integral, you can only integrate infinitely small things.
Yeah.
Yeah, this is all infinitely small things on both sides. Then you take it in, you integrate it. Then it becomes some finite stuff.
Yeah.
Yeah, when you here you have both sides are the numbers 1, 2, 3s, not infinitely small. How are you gonna take an integral on this? Okay, I'm just having some fun with your head. Okay.
So make it infinitely small.
How do you do it? You multiply the dt over. That's what we did last time.
Just divide everything by infinity.
You can't. Infinity what? You can't do infinity absolute, you know. In any way. You're just screwing around. Anyway. Let me ask you this question. Let me say a function. Any function. Right? Right? Of t. Let's just call the function mu, right? Of t, right? Then multiplied by y, right?
Yeah.
When I take a derivative of that,
Yeah.
right? What do you know how to open up this bracket?
Oh.
let's say this is y, this is mu, right?
Yeah.
Right? This is mu multiplied by y, right? Right?
Mm-hmm.
When mu and y increase a little bit, right? You're talking about something like this, right? This difference,
Yeah.
right? Against t, all against t, okay? So now, you see this? This is y, this is mu. It's mu dy. Hey, wait, this is mu. This is the y, sorry. Right? This is the y. This height is mu, right?
Yeah.
It's mu multiplied by dy. It's this area.
Yeah.
And y times d mu is this area. Right? So this equals to that.
Yeah.
Okay? I'm going to divide this by mu. All that I'm trying to do is to get the t on one side, get the y on the other side. That's all I'm trying to do. Okay, now I'm going to divide this thing by a mu prime. Okay? Look at this. This will be mu t, right? Y prime, right? Equals to y plus mu divided by mu prime, y prime, mu prime, right?
Yeah.
If, watch this, if this area is equal to this is the y, this is the y prime. Oh, I just did, what? I just did the other way. Okay, let me do this way. Sorry about that. Let's forget about this. I'm going to do this way, okay? Divided by mu, okay? Okay? Y prime plus mu prime, mu y, right? That makes sense?
Yeah.
See, look, compare this and this. If I can make this y prime, if I can make mu prime divided by mu equals to p, right?
Yeah.
Then I can use this way to put this y inside this derivative. Because this derivative, when you do it, it come up to two terms. Here we have the two terms. If we can put it back in, so to speak, this will work. Then this becomes the same thing. The y prime equals some t's. Right? You don't care about t's.
Okay.
Right?
Yeah.
So now, for this to happen, we need this. We need mu prime divided by mu equals to p. Right?
Uh-huh.
Right?
Yeah.
This is d mu. This is d mu. I'm gonna write a few more steps just so you don't get confused. Okay? This is all of these are functions of t. Okay? I'm just writing this up. Okay?
Yeah.
The next step I'm gonna do d mu. Okay? P dt. Right?
Yeah.
Okay. And we have the mu now. This one I have to take an integral because I don't know what p is. I'm just gonna take an integral. Right?
Okay.
I'm gonna just write this p t dt, right? Yeah.
Yeah.
So mu equals to, I'll just forget about this abstract value. We're not gonna deal with that. Mu equals to, there's a constant, there's a e to the p t dt. Okay?
Okay.
In other words, you put this mu into this whole thing becomes mu t times y. Right? Okay, now, when this is mu t times y, right? When this becomes this, now, we have the, let's see. this equals to gt. Let's see where we are. This equals to, now this equals to p now, right? So this equals to 1 over mu. This equals to g.
Yeah.
Right? G. Right? So this equation really is, I just rewrite it so this make it easier. And I write it in dy dt form so you see it. Right? This dy dx, this equals to this.
Okay.
And now I put the dt over on this side. Now I can take an integral of this.
Okay.
After I take an integral of this, it becomes mu t yt equals to this integral gt mu t dt, right? And I just divide the mu over. Yt equals to 1 over mu t integrate gt dt, right?
Yeah.
Okay. In any case, this is different from what I wrote down. But anyway, let's take a look. There's something wrong here. This equals to this, right?
Yeah.
And then I take the mu out, becomes this. Right. So it's like that. It's g over mu. This g over mu, and then we take integral. Then you divide it over. Oops, right. In any case, I think I'm right. There could be some mistakes in there, but anyway, it doesn't really matter. The point I'm trying, here's the mu, right? Substitute it in, so you solve the y.
Okay.
Yeah. This looks pretty convoluted, right? But actually, it gives a general idea about how to solve this equation.
Yeah.
Equation involve a 1 degree derivative and a y. This is linear, by the way. Consider the linear differential equation, general form. This could be a t function t here. Doesn't matter. You just divide them all, divide them down, then they become a new. Yeah.
Yeah.
Okay, I want to say a little bit more about this because I don't think we mentioned this when we were doing the differential. Let's say you want to take a derivative sine x and log x, right? You want to take a derivative of this.
Yeah.
Then you don't know how to do it, right? Anything that multiply together, you can use this formula. It's a sine x, you take a derivative, log x plus sine x log x, you take a derivative. Yeah, you take a derivative.